Thanks for taking a few minutes to watch this video that covers section 6.3, the problem solving with algebra section. I hope that this video will help you with the homework for section 6.3, and it'll also give you some good notes. If you'll write the notes down for this video, that's going to help you when you go to take the test, the unit test, or when you're going to do the homework for this section. So please do make sure that you're taking notes over this video. Now, if you are using the guided note pages, you could add these notes to the practice problem section. But that's not required. You could also just use your separate paper, because really those guided note pages are just there to give you a guide to make sure you're getting all the notes that you need. It just calls out the different examples that you should certainly have examples written in your notes for. But with the e-text having some problems with the links, the icons might or might not show up. All that you really need for your notes for these sections is you need to have the key terms written out. And then beyond that, it's just taking notes on the reading of the textbook, taking notes on the video that's assigned through the textbook, and then taking notes on this video that I'll make for each section. But if you're taking those notes, then you could do it on the guided note pages or on separate paper. This section is going to walk through some algebra word problems. And the first step to these algebra problems is being able to translate from an English phrase, a word phrase, to a mathematical expression. So I'm going to be really picky in this video about the order, even though addition is commutative. And when I say addition is commutative, that means that 3 plus 5 is, of course, the same as 5 plus 3. But for the fine detail of this video, I'm going to be really picky about the addition, the mathematical expression that uses addition with regards to which one we're going to list first. So when I say 6 more than a number, notice that if it's 6 more than, then it's got to be the number that starts first, and then we're going to add 6 to that number. So it's the number plus 6. So we've got to start with the number, the x, and then add to it. Or if we have a number increased by 3, we're starting with the number x and we're adding the 3 to it. So notice that although x plus 3 and 3 plus x are equivalent, we're going to be really careful to write it this way, the x plus 3. Now when we get to subtraction, it's important to note that 3 minus 5 is not equal to 5 minus 3. They're not commutative. What's actually true is that 3 minus 5 and 5 minus 3 are opposites of each other. But because subtraction is not commutative, it's very important that for these examples that are subtraction, the x minus 4, x minus 9, it's important that in these examples we're especially careful to put them in the right order. So 4 less than a number, you've got to start with the number x and then subtract 4 from it. Or a number decreased by 9, we're starting with the number and then decreasing the number. So we start with the x again. All these other examples I think are pretty self-explanatory until we get down again to this more subtraction. 3 decreased by a number, we start with the 3 and then subtract 6. Difference between, we're always going to just put those in the order they appear in the phrase. So it'll be x subtract 5, and so on. So read through these examples on the page. These just come straight out of your textbook, and make sure that you're comfortable with each of those. There is a Blackboard activity. Let me go back here to this to highlight that there is a Blackboard activity, and that activity is a one-page worksheet that walks you through some more examples of just this, the translating a phrase to a math expression. Some of you are going to find that to be very, very quick and easy because maybe algebra was easy for you, or maybe algebra was recent for you. Others may really struggle with it either because algebra has been a challenge for you before, or maybe it's just been a very, very long time since you've taken algebra. So if you do find any struggles with the activity sheet, please reach out to me, and I'm here to help you more. But I don't want to go too much more detail in this video because for many students, you just won't need that extra help with it. So let's look at some word problems. And first, let's look at a good procedure for word problems. We're really going to see that this procedure follows Polya's problem-solving steps. And we could group these together. So if you recall, number 1 for Polya was understanding the problem. And understanding the problem, in this case, is going to be this 1, 2, and 3 of the procedure is going to fall into this category of Polya's step number 1. So this 1, 2, and 3, read the problem carefully, draw a sketch to visualize it, and identify which quantity you're being asked to determine and represent it with a variable, and then write down exactly what that letter represents. So we'll actually write let x equal whatever, the missing number, or the number of milligrams needed, etc. But that all 3 of those steps really fall into Polya's step number 1. And then when we go to Polya's step number 2, which is to come up with a plan or devise a plan, that's where this number 3 kind of falls into that, where we're choosing a letter to represent, choosing the variable is part of this devising a plan. But then writing a word problem is part of devising a plan. And the other part of devising the plan is simply thinking through that for these algebra problems, the plan that we're going to come up with or devise is to write an equation. Then step number 3 is to carry out. So we had understand, plan, and now carry out the plan. The carry out the plan is this solve the equation. And then the last step, when we talk through Polya's steps of looking back, is going to be like this last step here, answer the question and check your solution. So as we look back, we want to make sure we've answered the question. So we're going to look back and check the solution also. So here's how we can relate Polya's 4 steps to this procedure for solving some algebra word problems. Let's just jump right in to an example here. A gallon of paint covers a surface area of 825 square feet. Assuming paint can be purchased in gallons, how many gallons are needed to paint a house with a surface area of 6,600 square feet? Well, the first step, I've read the problem, and you might read it a couple times just to make sure I understand what is going on here in this problem. And part of rereading this problem is I'm going to call out what is the question. How many gallons are needed is the question. This one doesn't really need a sketch, but I do want to identify which quantities are being asked for and name a variable. So I'm going to state let X equal the gallons needed. So that's that step number 3. Identify the quantity that's being determined. Choose a variable, a letter to represent it, and write down exactly what that letter represents. So this number 3 here is shown here. Let X equal the gallons needed. And now step 4, I'm going to write out a equation. And here's what I'm going to recommend to you for these proportions. So this example with the paint falls into this category. And anytime that any of the other problems in this section that have to do with a dosage are going to fall into this category. That I'm going to write a proportion, but I'm going to start with some labels. It doesn't matter if we put the surface area in the top or the bottom. But do you see that the two things being compared are the surface area and the number of gallons of paint? And the surface area is the feet squared, and gallons of paint is, of course, in gallons. So by writing that as a ratio itself, feet squared to gallons, or surface area to gallons of feet, it's going to make it really easy to get my proportion lined up, because the proportion is where I'm going to write two fractions equal to each other. Going to be very easy to get this correct by having those units there. So what we know is 1 gallon of paint covers a surface area of 825 square feet. 1 gallon of paint, 825 square feet. So we've got 1 gallon, 825 square feet. And then we're going to compare that to how many gallons are needed, so that how many gallons is X gallons. That's got to go in the denominator, because our gallons, as you can see initially and in our green setup, the gallons is in the denominator. So I've got to make sure it matches all the way across. How many gallons are needed to paint a house with a surface area of 6,600 square feet? And that's the hard part of this problem. If you can get it set up, then the rest will probably be pretty easy with algebra. You certainly want to use a calculator for this, but it's not a challenging algebra equation from here. The next step is I'm going to use cross multiplication. So I do the bottom of one fraction times the top of the other is going to be equivalent to the bottom times the top the other way. So that what I'm getting is, the reason it's called cross multiply is I'm multiplying across here and across here. So we're going to call that cross multiplication. Here's what it would look like is 825 times X equals 6,600 times 1. In order to solve for X, I'm going to use an basic algebra of solving an equation, and that's going to be to divide both sides by the 825. Now, just a quick review of that. I want to solve for X, so that means I want to get rid of this times 825, and that's why I'm going to divide by 825, because dividing will undo multiplying. So I'd be left with X equals, and I'm going to pull out a calculator. If I do 6600 divided by 825, I get 8. And now the last step, I'm going to make sure I answer the question, and I'm going to use a therefore statement to answer this question. Therefore, 8 gallons are needed. You could be more detailed if you want. Therefore, 8 gallons of paint are needed to cover a surface area of 6,600 square feet. But this is sufficient also just to state that answer. You can leave some of the detail out. But therefore, 8 gallons are needed. I'm going to check my solution by putting an 8 back in over here for x. And I would notice that 825 times 8 does in fact equal 6,600 if I put that into the calculator. And that's it. That's the first one. Let's try another example. Here's one using a dosage. So we're going to use that same problem-solving set of steps. Let's try this again. Doctor asks a nurse to give a patient 250 milligrams. The drug is available only in a solution whose concentration is 40 milligrams of simethicone per 6 milliliters of the solution. How many milliliters of the solution will be needed? So I could keep this really simple by saying that my big comparison is milligrams to milliliters, but probably makes a little more sense to also include the name. Though you in this one, you'd be okay without naming them because we've got milligrams for one and milliliters for the other. And the milliliters is describing this solution, right? So that lines up for me where I'm going to put each piece in this proportion. Give the patient 250 milligrams, and it's in the solution. Oh, I didn't really walk through the steps really carefully because the question is saying how many milliliters should she give the patient. So let's back up just a little bit. I apologize that I skipped that very important step of defining the variable. So let's let x equal milliliters of the solution. So do you see that I could put the x right here in the bottom because the milliliters of the solution is an x. And we want to know how many milliliters of the solution when there are 250 milligrams of this drug. And we can compare this to this concentration of 40 milligrams per 6 milliliters. So I can write that if I'm deciding, well, which one goes in the top, which goes in the bottom, the 40 milligrams has to go on top so that it's consistent all the way across, and 0.6 of a milliliter is going to go in the denominator so it's consistent all the way across. So here's my proportion, and now I can solve that proportion. Again, I'm going to solve it with cross multiplying. So I'll multiply 250 times 0.6. And by cross multiplying, we'd get that that's got to be equivalent to 40 times x, cross multiplying across this way. When I go to solve this equation for x, I notice that the x is multiplied by 40. So to solve, I'm going to divide both sides by 40. And when you put this on the calculator, 250 times 0.6, and then divide that by 40, I get that x is 3.75. So I can answer the question now. Therefore, the nurse should give 3.75 milliliters. Therefore, oh, I said therefore, and I wrote these 3 dots. If you're not familiar with this symbol where we've got a triangle where the bottom 2 dots are flat, and then 1 dot above it, that symbol is another way in math of just saying therefore. So you could write the word therefore out, or you could use that symbol. We could do this again with insulin, following the same steps. How much insulin would be given? Let x equal the insulin given. How much insulin would be given for the following doses? So if I were to write this out as a proportion, I forgot to jot this part down from example 6 on page 309 of our textbook. They explain what this U40 means, and the U40 means that our unit conversion is 40 units of whatever to 1 cc. So we could use this for any of the different problems. So if we're going to do 40 units per 1 cc, then the conversion that we'll use is the 40 per 1, and then what that's going to be equal to is whatever the different product is. We've got the number of units and how much insulin. So the bottom is the insulin part, the cc. How much insulin in cc? Let me highlight that. How much insulin in cc? So we can see that this x, the amount of insulin, matches up to the 1 cc. So this is how we'll set each of these up. But to do the cross multiplying, we do 40 times x equals 15. Solving for x, I'm going to divide both sides by 40. So on the calculator, 15 divided by 40 gives us 0.375. And so we would say for number 50, therefore, 375 thousandths cc of, in this case, insulin should be given. And that's it. Hope that you find those examples helpful. If you have questions, please reach out to me. I'm here to help you with the homework or with any of the examples you're working through. But I hope that these examples help you get a good start on the homework.